Hello and welcome, dear students. How are you all? Hello and welcome, dear students. How are you all? So, I welcome you to the class of biology. So, how is everybody doing? Okay. So, in the last class, we had studied the anatomy, the internal structure, the internal microscopic structure, cutting the transverse section and the longitudinal sections of the plant. So regarding that, let me give you a quick revision what we have done in the last class. Anatomy of flowering plants. Anatomy of flowering plants. Okay, so we have done the definition of tissue. Okay, I had given you a slide homework to find out. Have you done your homework? I had given you a slide homework to find out the origin of different blood cells. Have you done that? In the last class, I told you the definition of tissue. A tissue is a group of cells having common origin and function, right? So, tissue is a group of cells having common origin, but there is an exception to that, and that exception, it is called, it is known as blood, because blood has multiple origins, right? So, blood has multiple origins. Maybe you have done it, maybe you have not. So, tissue is the group of cells. Then I told you that tissue is of two types. It is meristematic tissue on the basis of origin. It is either meristematic tissue or it is permanent tissue. Okay, meristematic tissue is always in a constant state of division. Sometimes it may be dormant, as it is seen in the case of axillary bud. It is seen in the case of dormant buds lying in the plant, so that whenever damage occurs, these buds will suddenly become active. Okay. Now, permanent tissues are those cells which have been formed from meristematic tissues, and these cells have differentiated into the cell of root, into the cell of stem, or into the cell of leaf. Alright. So, meristematic and permanent tissue, there are two types of tissues, and permanent tissue is again classified into two types of broad classification: simple permanent tissue, then there is complex permanent tissue. So both simple and complex, I believe we have done. Okay, simple permanent tissue, it comprises of parenchyma, collenchyma and sclerenchyma. Alright, so parenchyma, collenchyma and sclerenchyma. Complex tissue comprises of either xylem and phloem. There are only two complex tissues in plants. Alright. So, these are the basic tissues that we have done. So, meristematic tissue has been completed. Permanent tissue has been completed. Okay. Meristematic tissue, I have told you that it is either on the basis of origin, it is of primary meristem or secondary meristem. On the basis of position, it is of three types. What are those three types? Do you remember? Apical meristem, lateral meristem and intercalary meristem. Okay. So there are two bases of classifying permanent tissue. Okay. Alright. So permanent tissues we were doing parenchyma, collenchyma, sclerenchyma. Okay. This has been done. Then xylem and phloem has been done. Okay. So this has been completed. So now we will move on to the next part. Okay. Just to give you a quick revision of xylem. Xylem is also consisting of four types of cells: xylem parenchyma, xylem fibers, these are sclerenchyma fibers, xylem vessel elements or xylem vessels, then there are xylem tracheids. Okay, out of these only xylem parenchyma is living tissue Otherwise, every other cell is what kind of tissue? It is dead tissue. In phloem, there are again 4 types of cells. These are phloem parenchyma, phloem fibers, then there is sieve cell element or sieve tube cells, sieve tubes. Then there is companion cell. Okay, out of these, only phloem fiber is dead tissue, otherwise these and these are living tissues. Okay. So up till this part we have done in the last class. Now what we have to do is the transverse sections of, we have to complete the monocot and dicot transverse sections. Okay. Ground tissue system, epidermal tissue system and vascular bundles, we have also done this. Okay. So based on this, we had done in the last class tissue systems. Tissue systems are of 3 types. First is epidermal tissue system. Epidermal tissue system. Okay, I believe we have done this also. So I hope you remember this. Then this is ground tissue system. Ground tissue system. And the third is vascular tissue system. So I believe we were doing vascular tissue system in the last class, right? We were doing vascular tissue system, right? So yeah, scientists, now please also report your attendance. It's quite some time now. Please report your attendance just quickly, and then I'll get on to the main topic today. Okay. Please quickly report your attendance. Taming Long, Shillong, other scientists, please report your attendance quickly. Okay, I believe everybody has come now. Okay, 8th in, okay, Shillong I can see. Yeah, 8 students in one and 10 in another. Okay, alright, great. So, Itanagar, Shillong, Taming Long. Itanagar, please also report your attendance. Okay, Itanagar 1 student and Taming Long 1. Okay, thank you. That is sufficient. Alright. So, tissue systems, when we talk about tissue systems, it is the grouping of tissue, it is a grouping of cells into specific kinds of tissues which form a part of their structure. Okay. So, suppose I consider my skin. So, what is present on my skin on the outermost side? It is epithelium. As I go inside, suppose there is a wound in your skin and blood is coming out. So, what thing do you see before the blood comes out? You see some kind of white colored cells. Okay, that is basically a part of your epithelium and the underlying connective tissue. If the wound is deep, you will see underlying connective tissue. Then deeper inside there are more tissues. Similarly, if I see in a plant, okay, Chira Chandpur, 5 students, great. Alright, thank you. So if I see in a plant, I will find there are 3 layers or there are 3 systems, okay, 3 tissue systems from outside to inner. On the outside there will be epidermal tissue system, okay. Epi means outer. In plants we call it epidermis, in animals we call it epithelium. So epidermal tissue system refers to the outer covering, the peeling, okay, that thin layer which covers the outside of any plant organ, whether it be root, whether it be stem, leaf, fruit, seed, anything, everything that is a plant organ. It's maybe, let it be a flower, let it be a meristem, everything is covered on the outside by epithelial tissue. Alright, and epidermal tissue, and epidermis is the outermost layer, and if it is any other organ than root, it will also contain a layer of cutin or cuticle. So epidermal tissue system, should I give you a quick revision? Epidermal tissue system it is the outermost covering, okay, it forms the outermost covering. I believe we have done epidermal and ground. I am just giving you a quick revision because vascular was not complete, and then we have to do the cross section. It forms the outermost covering of all plant organs, of all plant organs. Now when I say this, I also mean the stomata that are present on the leaf. They are also a part of epidermis. Okay. Suppose you have a slight bit of sweat coming on your skin. Okay. So sweat comes out from your sweat glands. They have a pore in your skin. Okay. So if you are sitting and you can see some drops on your face, on your friend's face, they are coming out from sweat pores, sweat glands. Similarly, water will come out from the stomatal pores present on the leaf. Stomata will be present on leaf only. Do not say it is on the stem. On the stem, different kind of pore is present. It is called lenticel. So, stomata, they are also part of the epidermis. Okay, and it is the most important epidermal tissue system part. Okay. So I had told you in brief about the epidermal tissue system last time. It forms the outermost covering of all plant organs. Write one more point. Except root, epidermis is always coated by cuticle. Cuticle is a shiny, waxy layer that you can find on the outer surface of epidermis. If you want to see the cutin, take a plum, take a peach, take an apple and look at it closely. You will see some waxy layer on the outermost surface. That is cutin or cuticle. Root, there is no necessity of cuticle because root is already in the soil and there is no danger of losing water from the root surface because it is in the soil. Soil is always cooler. Okay, but the overground part, it is exposed to wind and it is exposed to sunlight. So that is prone to lose water. So that is why we have cuticle on every other plant part except the root. So I told you that epidermal tissue system, the most important part of the epidermal tissue system are the stomata. And stomata we have to study. There are two types. One is the lens shaped stomata, which is the most common stomata in dicots, and the other stomata is the dumbbell shaped stomata, which is seen in the case of grasses, monocot grasses. This layer, the inner layer, it is quite thick. The inner cell wall is very, very thick. Okay, it is very, very thick. And there are the subsidiary cells. These cells are called the guard cells. Guard cells. They are also green in color. I have not shown them with a green color, but they are actually green in color because of the presence of chloroplasts. And this small space, it is the opening called stoma. Plural is stomata. These cells that are present here, these are called subsidiary cells. Subsidiary cells. So what is stomata? This is stomata of dicots. Okay. So you will write here, guard cells are modified epidermal cells. Guard cells are modified epidermal cells forming stomata in plants. So stomata is a breathing pore. It's also breathing pore. It's also a pore for water loss. Okay, it is meant for losing water also, and it is also a pore for taking in air and giving out air, exchange of gases. So what is stomata? Please write next. Stomata or singular word is stoma, singular is stoma, plural is stomata, are pores meant for exchange of gases and transpiration. These are the pores that are meant for exchange of gases and transpiration. So this is the stomata of dicots. Okay, it is lens shaped, and when I've drawn a thick black line, it means the inner wall is quite thick. Now please try to understand the working of stomata. When the cells are turgid in condition, I will also teach this in translocation of solutes and osmosis, everything else will be taught there also, but just to give you a fair idea up till that, in plant physiology this will be covered. When the stomata are fully turgid, that is there is no water shortage for the plant. In that condition, these cells will open like this. But when there is shortage of water, the outer covering, it is having thinner cell wall. So water will escape quickly from the outer surface, this cell, okay, this surface, and from the inner it will not escape very quickly because this is very thick cell wall. Also, because of this thick structure, when the cell loses water, it will not collapse. It will not collapse like this. It will not collapse like this. It will in fact grow elongated. If it was not thick, it would have collapsed like this. Okay, there would be no opening. But because it is thick, when the cell loses water, instead of collapsing, it becomes longer. And when this happens, the stomata will be closed. When the cell is turgid again, it will again open like this. Okay, so this is the mechanism for opening of and closing of stomata. This is oversimplified. In the plant physiology, I will also teach you that it is because of uptake of potassium and malate ions. That will come later. Right now, this is sufficient for you. So these are the pores meant for exchange of gases and for transpiration. Stomata is lens shaped in dicots, and there is another kind of stomata which is dumbbell shaped like this. Dumbbell shaped stomata, and this is the stomata which is found in the case of monocot grasses. Here also there is extreme thickening in this region. This cell wall is very thick, and the subsidiary cells are of different shape also. The subsidiary cell here, it is of this shape. This is the subsidiary cell, and this is the stoma. Subsidiary cell, guard cells, and you can write this is the stomata of some monocot grasses. Okay, showing dumbbell shaped guard cells. dumbbell shaped guard cells. Okay. So this is epidermal tissue system. Next, please write ground tissue system. Ground tissue system. So why we studied stomata? Because stomata are modified epidermal cells, and epidermis is the outermost covering of the plant organs. And there are some special modified epidermal cells which are called guard cells. There is another type of epidermal cells that are found somewhere in some special grasses, which have the property of folding their leaf in water shortage condition. These are called bulliform cells, and this I will teach you, and I will give you the I will shortly give you the monocot leaf cross section. Okay, so then I will cover this ground tissue system. So please write it quickly. Let's see how much diagrams we can complete today. Ground tissue system. So in the ground tissue system, please write. If you miss anything, please tell me to scroll up. Okay, in case you miss anything, please tell me to scroll up. Ground tissue system. All the tissues except epidermis and central vascular cylinder come under ground tissue system. Ground tissue system. Okay, it comes under ground tissue system. All right. So not much to write in this. It will be hardly asked. It includes cortex, parenchyma. Okay, all things included in ground tissue system like this. Now the most important part, the vascular tissue system or the vascular bundles, and from this you can expect a very short question or an option. I will just give you the diagram, and this diagram will be sufficient for any type of question that is asked from vascular tissue system. Okay. It should be more than sufficient. Now vascular tissue system, what is vascular tissue or vascular bundle? Xylem and phloem together comprise or form the vascular bundle. It is also associated with other tissues also, but the xylem and phloem, they together form the vascular bundle, and this is what we have to study. All right. So now we have to study some arrangements of the vascular tissue. All right. So please write. All right. So now we will do some types of vascular bundles. So there is a chart that you have to draw. Okay. So there are two types of vascular bundles. One is called radial, other is called conjoint. Okay. There is one more also, it is called concentric. So types of vascular bundles. Types of vascular bundles. I'll do this in the next page, otherwise this will become very short. Types of vascular bundles. The first type that we have to deal with, it is the radial vascular bundle. Radial vascular bundle. The radial vascular bundle, okay, there is a problem. Wait a second. Wait a second. Okay, I hope it is visible now. Right. So radial vascular bundle. In short, I will write it VB. Okay? Radial vascular bundle. In radial vascular bundle, the situation is like this. This is a cross section that I am showing you of the vascular bundle, of the location of the vascular bundle, and in this there is a condition. Let us draw it by black only. Xylem I will draw by black. Xylem I will draw with black. Like this. And phloem I will draw with red. This is phloem and this is xylem. Okay, this is xylem and this is phloem. So see carefully here. Okay, yeah. See, I said that I would do with dicot root. Okay, yeah. I'm coming up to that. I'm coming up to that quickly. So in this radial vascular bundle, this is the characteristic feature of which kind of root? It is the characteristic feature of dicot root. Yeah, I know that. I told you that I would be dealing with the dicot root, but before that I needed to give you a quick recap of this, because there were some people, I believe, who had not attended, so they were confused about this epidermal tissue system and its context. So I had to deal with that also. Now this radial vascular bundle, it is found in roots, whether it is monocot root, whether it is dicot root. It is found in both kind of roots, monocot plus dicot. Monocot plus dicot root. Alright. And I have already told you that in this kind of vascular bundle, phloem is present on different radius and xylem is present on the different radius. The other kind of vascular bundle is the concentric vascular bundle. Concentric vascular bundle. And there is a third type of, there is other type of vascular bundle called conjoint vascular bundle. Conjoint vascular bundle. In this, both xylem and phloem are present on the same radius. Okay, both xylem and phloem are present on the same radius. Conjoint is of actually two types. One is collateral, one is bicollateral. Collateral, bicollateral vascular bundle. And in collateral also there is open vascular bundle, there is closed vascular bundle. Collateral open, collateral closed, and bicollateral open, bicollateral closed. So in collateral, if I take a look at the vascular bundle, if it is open vascular bundle, then that means cambium is present. Cambium is present. Cambium I am showing by purple. And if it is closed vascular bundle, there is no cambium. There is no cambium. Bicollateral is of this shape. There are two phloem patches. In open vascular bundle, there is cambium here. So I will draw some cambium here. Cambium by purple. In the middle there is xylem, and outside there is phloem, like this. In closed vascular bundle, there is no cambium. Okay. These are the two types of main vascular bundles that are in your course. There is a third type also, it is called concentric vascular bundle, but that I have not included here. Okay. Purple is cambium here. So cambium is present here. This is cambium. This is cambium. This is cambium. Okay. So now we will do, finally, these are the types of vascular tissue system, the vascular bundles. Finally, we will deal with the transverse section of root, and then first dicot root, then monocot root, then stem, monocot dicot. So please put the heading transverse section of dicot root. When I say transverse section of dicot root, this means the type of vascular bundles that will be present. The type of vascular bundles that will be present, it will be like this. This type of vascular bundle will be present here. Okay, this type of vascular bundle will be present in the roots. So that is what we are going to draw in here also. So first, please pay attention to what I am going to do here. Okay. First of all, the dicot root, on the outermost side, there is the epidermal layer. Epidermal layer. As you move inwards, there is a cortex. Then the cortex cells consist of large amounts of parenchyma, I will show you here. Then there is endodermis, then there is pericycle, and then there is the vascular bundle. So inside you will see the vascular bundle of this shape only, and it is very easy to draw. I am just drawing it. Okay, so please use a full page for this, and don't draw a diagram exactly in the middle. First I am going to draw the outline. Just a second. First I will show you the outline, and then I will give you the complete picture. On the outermost surface there are some hair-like structures on the epidermis. These are the root hair. Okay. The transverse section of dicot root, on the outermost surface there is epidermis. So these are the root hair. You can label it here. Root hair. Okay. And this is the epidermis layer. The next surface here is after this comes the cortex. So before drawing the cortex, I will draw the endodermis. This is the endodermis layer. And this whole part, this is the cortex. Up till this to this part. This is the cortex. Okay, my diagram is a bit shifted to the left side. Okay, I hope it is visible. This is the cortex. Just a second. This is the cortex. Okay. It is visible to everybody, right? Okay, a minor part of the circle will not be visible. This is the cortex. So let us draw the next things. Endodermis is done. Then there is the pericycle here. Let me draw the pericycle. Pericycle will choose a different color. So pericycle. Okay. Pericycle cells are also just below the endodermis. So this is pericycle. Here. Now we have to draw the vascular bundle. So the vascular bundles that are present here, these vascular bundles we have seen in the diagram that I have shown you. Now I will show you the structure of that vascular bundle. First, let me draw the outline. The vascular bundles that are present, it is shown like this. Xylem is shown like this. Okay, this is xylem, and this is the phloem. Phloem is present here. So if you cut a dicot root cross section, and if you do look at it under low power microscope, you will see this kind of structure. Now what I am going to draw here, it is the section going from the epidermis to the central layer, central cylinder. So it is going to be like this. I am going to cut a section. I will just use a marker here. Okay, I am going to cut a section like this. This part I am going to show you on the left hand side. This part is going to be shown here. So now see the layers that are present. Epidermis, first of all. This is the epidermis. And in the epidermis, some cells are modified into root cells. These are modified into the root cells like this. Just a second. Okay. All right. So I hope it is. Yeah. So now it is visible to everybody, right? Chura Chandpur. Now it is visible, right? Okay. So look, it's a big diagram. The thing is, you have to take up section of this here, all right, and draw it on the next page. So because the diagram is too big, what I will do is I will draw it in the next page. Okay, this diagram I am going to draw in the next page. Okay, so there is a, because it is not visible to everybody, and I have to do a lot of labeling also. So what I will do is I will do this diagram in the next page. So let me do it here. This much you have drawn, right? The left hand side, you have drawn this, right? Okay. So yeah. Now what I can do is I can draw this in the next page. So this, what you are seeing here, I am to take the yellow colored part that I am going to draw here. Alright. So I hope it is visible to everybody now. First of all, we will draw the epidermis like this. Just a second. It's not coming perfectly well. These are the thin epidermal cells. Because it is the root, there will be no cuticle here. Because it is the root, there will be no cuticle here. So I am not drawing any cuticle layer here. Okay. Now some cells, they will become modified into the root cells. Root hair cells, sorry. Every cell is a root cell actually. So students, if you are not able to see any part, let me know quickly. I will pay attention to that. Okay. So these are the root hair cells, elongated epidermal cells. Root hair can be very long, but still they will be unicellular. They may be very long, but still they will be unicellular only. So this is on the middle I have shown a growing root hair, and then the right hand side I have shown a full length root hair. So this is the root hair. Then inside this is the cortex. So cortex I am going to use a different color. So first of all let me label. This is the epidermis. Epidermis. This is the root hair. Okay. Modified epidermal cells. And this root hair is unicellular. Now I am going to draw the cortex cells. These are the cortical cells. Cortical cells, like this. Cortical cells, cortex. So cortex is many cell thick, cortical layer is many cell thick, and all these cells you can see there are large intercellular spaces. There are large intercellular spaces. Okay. So there are large intercellular spaces here. Okay. This is the cortex. Right. So now as we grow deeper, there will be a layer of cells which will differentiate itself from the cortical cells, and these cells are parenchyma cells only, but they have modified for a spatial function. So this is going to become a separate layer. This layer is called the endodermis layer. Okay. So endodermis layer, let me choose a different color. Let me take purple is good, I think. So what I have to draw here is like this. Actually this will come out in the form of a huge circle. So what I can do is I can maybe I will have to use the full length of the page. Just give me a second. So what I have to do is, just a second. Yeah. Right. Okay. Yeah. So I have to draw a circle here. All right. So this circle is not a circle. It's just a bit difficult to draw. Alright, yeah. Now it comes almost as a circular shape. Nearly, not perfectly, but I hope you'll excuse me for that. Okay. I'll now correct this in fragments. Yeah. So now this is fine. This layer, the outermost layer, of these cells, it is the parenchymatous modified layer called the endodermis. So endodermis cells are going to be shaped like this, like a barrel. This is the actual shape of the endodermis cell. These cells I am going to draw here. Okay, these cells are what I am trying to draw here. Okay, so these are barrel shaped cells. Okay, I am going to draw it like this. Barrel shaped cells like this. Okay, this is how you will draw it. Barrel shaped cells like this. There is going to be a huge layer like a ring, a giant ring. Okay, so this is the endodermis layer. Endodermis layer. Like this. Now inside this endodermis I am going to draw the pericycle first. So pericycle I am going to choose a different color again. Pericycle I will choose color like this. This is the pericycle layer. Okay, this is the pericycle layer. Now these cells, you can say that they are also sticking to the endodermis and they form a ring like structure. So actually they might be not just single layer, they might be about 2-3 layers of pericycle. I am going to draw just one here, one is more than sufficient. Okay. So cortex, up till this part, I hope you understand, okay? Because I have taken this yellow colored part. Just let me show you the previous image. This is the yellow colored part, right? So I have to draw the whole cortex up till the pericycle and the whole central cylinder. Okay? Alright. So doing about that again. Now we have to do a lot of labeling also. Now first let me draw the most essential part of this diagram, which is the xylem vessels. Xylem vessels. So xylem vessels I am going to draw here first, like this. Xylem vessels. Okay. Now you can see as we move towards the outside, the diameter of xylem vessels is decreasing. The diameter of xylem vessels is very quickly decreasing, right? The outermost thin xylem vessel, it is called protoxylem. The central thicker xylem vessel, it is called metaxylem. So this is the metaxylem vessel. Now I will draw 4 rays like this. This is the first one. There will be a second one opposite to this, like this. Okay. Then there is going to be a third one here. Like this. Fourth one like this. Okay. So this is the xylem vessel. Okay, central one is the metaxylem, the outer one is the protoxylem. Protoxylem. Okay, like this. Like this. Like this. Right. Now I am going to draw the phloem. Phloem, as a convention, I am always using red color, like this. 4 phloem patches and 4 xylem patches. It is called tetrarch condition of xylem and phloem. Tetrarch condition of xylem and phloem. Tetrarch condition of xylem and phloem. Okay, phloem is easier. Draw very small. To draw phloem, do it like this. Draw phloem like this. Draw very small circles like this. This is going to be phloem. Okay. This is phloem. Because this is dicot stem, this is showing tetrarch condition. Now I will also tell you the importance of pericycle layer in this. Pericycle is very, very important here. I will come up to that later. Let me complete the rest of the diagram now. Now whatever part is remaining here, we have to fill it first. So this is the cortex. Let us complete the cortex. This is the cortex. So cortex is almost done now. This is the cortex. Now the rest part in the middle, that is called the pith. That is called the pith. So pith is very reduced in dicots. Pith is very reduced in dicots. Rest of the cells that I am going to draw here, they are not very significant, so I am going to use a color that you cannot see on the screen very well. Okay. Alright, so I am going to just draw it quickly. These are random cells that I am drawing like this. This is called actually the conjunctive tissue. Conjunctive tissue. The cells are like this. Very small cells, polygonal cells. They just fit and interlock with each other. So I am going to just fill this space here. That is, I am drawing this. You can draw crisscross lines also like this, just to complete it. So this is the conjunctive tissue. Now we will quickly label all the cells that are present here. The diagram is completed now. The root hair is done. Epidermis is done. Now we have to label the cortex. So let us label this region is called the cortex. Cortex. Okay. Now this layer of cells, it is called the endodermis. endodermis. Okay, and inside this endodermis, this layer, the blue colored, light blue colored, I'll maybe use the same colored pen so that you don't get confused. This layer, it is called the pericycle. Okay. Now this part, it is called the phloem. This cell, it is called metaxylem cell. Metaxylem vessel. This cell, the shorter diameter cell, it is called protoxylem. Protoxylem vessel actually. Metaxylem and protoxylem. This cell is also protoxylem. All the smaller cells on the periphery, these are the protoxylem cells. Okay. The central part that I have drawn here, it is called the pith. Pith. Okay. This is the complete diagram. Okay. So please draw it quickly. I hope everybody has drawn it. You must have completed faster because I have a large number of things to draw. You might only have to label it. Okay. So this is the transverse section of a dicot root. Now we will write the characters of this dicot root. Okay. So please do it quickly. It's a bit time taking, but if you just do it once along with me, you will never forget the main points that have to be done here. Okay. Now this is the vascular bundle that we had drawn up in the beginning of the class. Okay. So we had drawn this kind of shape. We had drawn this kind of shape like this. Okay. This kind of shape we had drawn. Alright. So what it actually means is that the inner side vessels are very large. Inner side vessels are very large and the outer vessels are smaller, like this. This was the meaning of it. And that is what we have done here. That is what we have done here. Right? The outer vessels are very thin. Alright. The outer vessels are very thin and yeah, like this. Okay, it's gone too muddy, too cloudy, like this. Okay. This is the condition of xylem. Alright. This is the condition of xylem. So that is what we have done here. Right. That is what we have done here. Xylem and phloem are present on different radius. Okay, this is a radial vascular bundle. A radial vascular bundle. So I hope everybody has drawn. Okay. Alright. Thank you, Taming Long. I can see. Okay. Thank you. Okay, time. So right, so time is done for this now. Now please write the description, the things that we have to know about this. So the description we have to write now. The outermost layer of dicot root consists of epidermis, some epidermal cells, some epidermal cells convert into root hair cells which are unicellular root hair cells. Because this layer of epidermis forms the root hair, it is also called pyliferous layer. Epidermis, also called epidermis of root, because it is forming hair like structures, it is also called pyliferous layer. Root also called pyliferous layer sometimes. Okay, because it is forming root hair. Now after the epidermis, what is the layer? It is the cortex. So you will say next to epidermis lies the cortex layer, consisting of large cells with intracellular spaces and thin cell wall. The parenchyma cells. The inner, next to the epidermis, so next to the cortex lies the endodermis. So you can say the innermost layer of cortex gets modified into endodermal cells, endodermis or endodermal cells. Endodermal cells are barrel shaped. The cells of endodermis, are barrel shaped. Also there is a unique thing here. The endodermal cells, they contain a cork, deposits of cork in the form of Casparian strips. Does everybody understand what Casparian strip is? Do you understand what Casparian strip is? Yes or no? No. And yes, maybe. Just raise your hands if you know what a Casparian strip is. I won't have to explain right away. If you know it, just raise your hands. Okay, nobody knows what a Casparian strip is. Okay, just write the statement, then I'll explain what a Casparian strip is and what does it do. Are barrel shaped. The radial and tangential walls, of endodermis are coated with a waterproof fatty substance called suberin. With a waterproof fatty substance called suberin. In form of Casparian strips. Okay. So let me explain what a Casparian strip is. Do you understand how a hydroelectric dam works? Do you understand how electricity is generated with the help of a hydroelectric power dam? Do you understand the principle? Everybody understands the principle of potential energy, right? So the thing is, when a dam is created, first of all we collect a large amount of water, okay, and that water is allowed to flow through a small space. Compared to the volume of the river, we allow the water to go through a small space with a high velocity, and underneath there is a turbine which rotates, and this mechanical energy is then converted into electrical energy. Alright. Now plants have also got this requirement of loading water with high velocity into the xylem. Okay, they have this requirement to load they have to load this water into the xylem. Now there is a problem. The problem is, if we load this water, how are we going, because the xylem is present at particular places. So if you allow the water to come from every direction, the xylem will not be filled properly. So to resolve this issue, plants have done a exercise. What have they done? So let me tell you about this. I will have to copy this diagram completely. Okay. Yeah, so we have to copy this. Okay. Now just a second. I can show you this in the next. Yeah. So the thing is, okay, give me a second. Yeah. So the thing is, what happens is, I'll show this with the help of, okay. Now we have some requirement of marker, right. Now please see these cells very carefully, the endodermis cells. Now the endodermis cells that are present here, I have to make a coating of suberin. So I will coat it like this, here, 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 and here. Wherever I am drawing this green line, it means I am coating some fatty material called suberin here. Okay. Here, everywhere I am coating it like this. So these cells, they have, look, a cube has 5 sides. A cell has, suppose a cell, this cell is cuboidal, then 5 sides are coated with suberin, and because a cube has total 6 sides, one side is not coated with suberin. So that is why this cell will remain living. If all the 6 sides were coated with suberin, then cell would be dead. But this is not dead, it is living, because one cell surface is still not coated with suberin. So all their surfaces which are facing the cortex, except for this cell that I am coating with pink, this cell, see this cell here, see this cell here, okay, and one more cell here, yeah, this is also pink, not green. These cells are not coated with suberin. These cells are left out as such. These cells are not coated with suberin. So what will happen? If they are not coated with suberin, water will enter from these places. Now I will show you the direction of movement of water. Water comes like this. Water is coming from root here, from here to parenchyma cells everywhere. It is coming from everywhere. Okay, wherever root hair are there, they will carry a lot of water inside. Now the water is coming from every direction, but ultimately it will go to this cell like this. Ultimately it will follow this direction because all the other cells have been blocked. They are waterproof. And here also water will enter from here, because the other places have been blocked. The pink colored cells, the cells which has not been coated with suberin, it will allow for greater faster movement of water. It will allow for greater faster movement of water, and water will flow from force into this cell, and these are called the Casparian strips. The green colored part, it is the Casparian strips, and the pink colored part is the opening in the Casparian strip. So it allows for faster loading of water into the xylem vessel. Are you getting me now? Okay. So this is just like a dam, just like a hydroelectric dam allows the water to flow with greater velocity at a particular point. So this is also using that same principle. This is the principle of Casparian strips. Is it clear to everybody now? It is clear to everybody, right? I can move on, right? You have understood Casparian strip principle? Okay, I hope you have. Alright. So this is Casparian strip, how it functions. Okay. So radial and tangential wall, that means the radial wall means outer wall, tangential wall means just like a circle, the inner wall. Okay, just write it, it's more than sufficient now. Suppose this is a cell, suppose this is a endodermis cell, then this is the radial, this is the tangential wall, this is the circular part, this is the tangential wall, and this part, it is the radial wall. So both radial and tangential walls are coated with a waterproof fatty substance called suberin. Only this part, light blue part, it is not coated. So that is how it happens. Okay, alright, so carrying on. In the form of Casparian strips, next to the endodermis, lies the pericycle layer of cells. The cells of pericycle are also parenchymatous, and they may be many layered in thickness. Pericycle is formed by multiple layers of parenchymatous cells, okay, and there is one more thing that you need to know. Look, have you seen old trees? If you see old trees, you can see at the base the roots that are coming, the roots also become woody in nature. For example, you're stepping on the ground in some forest, and you might have stepped upon some roots of like Ficus bengalensis. The Ficus bengalensis is the banyan tree or the peepal tree. Many types of trees you must have come across around in your daily life, and you might have played along with some trees also, and you might have taken a nap or something in your trekking experiences. So you must have definitely come across trees that have woody roots, right? Everybody has seen large trees having woody roots. On the ground there are thick roots which also develop wood. Everybody has seen them. At least once in your life you must have seen somewhere, right? Okay, what I am trying to tell you is actually dicot root and dicot stem, both undergo secondary growth. Both undergo secondary growth. But secondary growth, as you might already know, is due to activity of cambium. And if you see this diagram carefully, there is no cambium here. There is no cambium here. Right? Is there any cambium? There is no cambium here. No cambium in this diagram. So, yeah, okay, great, you have seen. Alright. So, there is no cambium here. Still, it is undergoing secondary growth. So, how it is possible? So, now you will write pericycle cells become modified into cambium cells. They form cambium ring, which causes secondary growth in dicot root. In monocot root, pericycle will never convert into cambium. This means in monocots there will be no secondary growth in neither in stem, neither in root. So let's write this down now. Parenchyma cells, and the cells of pericycle, the cells of pericycle become modified in older roots, and dicots only, not monocots. In older roots, bracket you can write dicot only, to form cambium ring. Cambium ring responsible for secondary growth in dicot roots. Okay. Also, pericycle is also important for forming lateral roots or branches of roots. Branches of roots formed by pericycle. So, you will write this also here. Yeah, I have to rub it. And then I'll have to draw it again. But now I won't waste so much time on it. You just have to copy paste, because monocot root by chance also has the same structure. Okay. So, responsible for secondary growth in dicot roots, you can say here. Also, lateral roots or branches of primary root, lateral roots or branches of root come out from pericycle. So this is called endogenous origin. Endogenous origin of root branches. Root branches have endogenous origin. This is in contrast with shoot branches or branches of found on the stem or tree. They are exogenous origin. What does this mean? Can you have an fair idea of this? What does this mean? This means it is easier to break always the external things. So it will be easier to break a branch than to break a root, because root is going to come out from inside. You will have to apply a large quantity of force. Even then it will not break easily. Shoot branches are easier to break because they have grown from the cortex. Exogenous origin. Roots are difficult to break. Branches are very difficult to break. If you pull it, the whole root will come out by itself, because it is having endogenous origin. It is coming from inside the pericycle region. Okay, that is the theory of it. Endogenous origin of root branches. Now inside of next, you can write just simply, next comes the vascular bundle okay, and vascular bundles, there are 4 patches of phloem and xylem each. In sunflower root, this root that I have drawn, it is basically sunflower root. Sunflower is a dicot. So normally we see 4 patches, sometimes we might also see 2 patches also, but this is the most common condition. So you can say this is called tetrarch condition of root. 4 vascular bundles. Tetrarch condition of root with respect to vascular bundles. Tetrarch condition of root. When we'll see the dicot root, in that you will see polyarch condition or greater than hexarch. Hexarch we don't write, we normally say just polyarch, simply polyarch condition. So now what I have to do? I have to now complete the transverse section of monocot root. Okay. So now it is going to be very easy for me. See how quickly I can draw the diagram now. So what I have to do is like this. Just a second. Okay, so alright. So I have to draw this, and by drawing I mean alright, this. Okay, so let's draw put the heading transverse section of monocot root. And surprisingly, the transverse section of monocot root is very, very similar to the dicot root. And what is the change here? The only change is like this. Only change is in the center. So that is I am going to make some changes here. Pith is going to be very, very expanded here. That is why I draw the pith with pink color. I have to make a lot of changes here now. See them carefully. Only in the central cylinder I will make some changes. The rest of the diagram will be exactly I was drawing in case of dicot root. So let's take a look at these changes now. Alright. So now everything you will already be able to comprehend. This is the root here, this is the epidermis, this is the cortex. Now pith will become very expanded. I am going to draw also a greater number of xylem vascular bundles and phloem vascular patches. I am going to draw a total of 8 vascular bundle patches here. Okay, that is what I am going to draw over here. One, two, three, four, five, six, 7. 1 remains. Okay, this is the xylem. Again, the same story. Metaxylem, protoxylem, same thing. Okay. Next, let me draw the phloem. Phloem is like this. 1, 2, 3, 4, 5, 6, 7 and 8. Like this. Like this. Like this. Okay, so phloem is having a 8 phloem you are going to draw similarly like you draw in dicot root. Okay, all right, so this is done now. Now pith is going to be very expanded here. So pith, I'm going to draw the full part here now. Pith is going to be very expanded. So you can draw very large cells in the center. And these cells will be slightly lesser in diameter as you come to the periphery. Okay. So most largest cells will be in the center. Okay, so you can draw it like this. Like this. Pith, you can see it is very much expanded here in monocots. Phloem is having a larger number here also, and this is the metaxylem. Metaxylem. The shorter one is the smaller one is the protoxylem. Protoxylem. Okay. So my diagram is complete now. Okay, it's up to you now to draw it quickly. Many people are not happy, I believe. This is the transverse section of monocot root. I have to make only a small changes. Even if I had drawn this on the blackboard, I would have only rubbed out the central part, and I would have made changes, and I would have told you like this is the diagram that you have to draw. You have to draw it in 2 pages. I would have to use only a single page. But in case of monocot and dicot stem, I cannot do the same thing because both diagrams are totally different. I can do this only in the case of monocot and dicot root because the rest of the things they are exactly the same. I will write the description also. The rest of the things they are exactly the same. Only difference lies in the center. Okay, the number of vascular bundles and the pith. 2 differences. Okay. So please write it. Please draw it quickly. As soon as you draw it, let me know, and then I'll make you write the description of this. Okay, so please do it quickly. All right. Okay, so have you drawn it? Should I move to the next part? If you are still drawing, I can maybe make some changes. Not changes, actually, just improving the quality of the diagram. I can just fill out these spaces like this. Protoxylem, metaxylem. Protoxylem, metaxylem like this. That's all I have to do. Pericycle remains the same. Okay. Pericycle remains the same. Right. So you have drawn it, right? Just let me know quickly. I believe the chat is not working. Maybe it is freezed a bit. So, are you able to listen to me? Are you able to hear me out? I cannot see any on the chat. So, I believe there is some issue. I'll just, okay, Shillong droppers. I'm just. Is chat working? I've just posted a message on your group, Shillong droppers. Okay, so I'll just continue the description. I hope you have drawn it. Okay, so please you can reply here. Drawn the diagrams, have you? Have you drawn the diagrams? Okay. Alright, so Churachandpur, Itanagar, okay, alright, so let's write the description here. I believe the chat is frozen, so please write the description now. Okay. So, the structure of the monocot root, okay. So, you can please write the description now. Structure of the monocot root is very similar to the dicot root with a few differences. Very similar to the dicot root with a few differences. Few differences only. With a few differences only. So, what are the differences that you can see here? The dicot root is tetrarch while the monocot root is polyarch. So, we can write here. The monocot root is having polyarch condition. Is having polyarch condition. Having polyarch condition. Okay. More than 6 vascular bundles. Greater than 6 vascular bundles. Both vascular bundles are radial. The vascular bundle in root is radial, whether it is dicot, whether it is monocot. Both have both have radial vascular bundle. There is no difference in monocot root with respect to radial vascular bundles, no difference. But number of vascular bundles is more, greater than 6 vascular bundles. So greater than 6 means more than hexarch, called polyarch. Also, pith is very well developed in monocots. Pith is very well developed in monocots. Okay. The third difference that you can see here, the third difference that is present is with respect to the cells of pericycle. The cells of pericycle never undergo secondary growth. Third difference you can write, major difference. The cells of pericycle do not convert into cambium. Hence, there is no secondary growth in monocots. There is no secondary growth in monocots. Alright. So this is with respect to the transverse sections of root. And if I draw the general diagram of the monocot root, like I had drawn the diagram of dicot, so you can see it is going to be just like this. It is going to be just like this. Epidermis. Okay. Next to epidermis will be the cortex. The innermost layer of cortex is called endodermis. So after that comes the pericycle. So pericycle, let me choose a different color. This is the pericycle. Then the pericycle will have a lot of vascular bundles. So vascular bundles are going to be like this. 1, 2, 3. So it is not circular, just don't mind it. 4, 5, 6, 7, and maybe put one here, 8. Then phloem will be present here. Sorry, phloem I am going to use red color. Phloem is present here, radial vascular bundles. Okay. Pith is present everywhere, like this. So this is how it is working. Epidermis, root hair, cortex, endodermis, pericycle, and the pith. Okay. So this is the general structure. Just there is only the change in the number of vascular bundles. Otherwise, there is no change. Okay. Only the number of vascular bundles have increased from 4 vascular bundles to 8 vascular bundles. Okay. Next, now let's put the heading transverse section of dicot stem. Dicot stem. Okay. So when I talk about the transverse section of dicot stem, let's try to understand this. Um, we won't be able to draw the full diagram, so we can do something else. TS of dicot stem. So first let's draw the clear-cut diagram, the line diagram. So I'm going to draw it like this. Alright, so yeah, it almost came in the form of circle, thankfully. Alright, so the outermost layer is called the epidermis again, and here on the epidermis there are many hair-like structures. Sometimes, suppose sunflower, it is having this 3 cells, 4 cells, 5 cells, 6 cells, or even more. These are the stem hair or the trichomes. I am not going to draw the cellular structure, I am just wanting to tell you. There are some hair-like structures here, and these stem hair are multicellular. These are multicellular hair on the stem. Now inside the epidermis lies a layer called collenchyma. This is the collenchyma. Collenchyma is also green colored. That is why I am choosing the green color to draw it with. Collenchyma is a part of green leafy stems. Green leafy stems. Green leafy stems. Like this. This is the collenchyma. So you can label it also side by side. Stem hair, also called trichomes. Epidermis, collenchyma, Now starts the cortical part. So after this lies the cortical part. So cortex, I am going to draw it with different color. Let's choose some other fine color. So this part is the cortical part. Cortex is going to be very well defined here. It's also consisting of parenchyma cells. Just choosing the colors to represent it, because otherwise it's quite boring, as already you know it. By the way, this looks like a chemical called, it's a quartz form. It's just looking colored like that, like a form of quartz, and there are, alright, so anyway, so first of all there is collenchyma, then there is the next thing that is present here, it is the cortex, and after the cortex starts the basically the endodermis, and then there is the pericycle. Okay, so these parts are present here, right? So you can say next part will be the pericycle. So pericycle I will draw with, pericycle is thin, so I am going to draw single line. This is the endodermis. Then inside the endodermis there will be the pericycle. So pericycle, let me choose again a different color. Let me choose pink now. This is the pericycle. And inside the pericycle, one more thing here, pericycle will not be continuous here. Pericycle is broken. So this will be discontinuous. Discontinuous. And wherever pericycle will be there, a vascular bundle will be facing it. A vascular bundle will be facing it. Okay. So let's draw the vascular bundles. Finally, we come to the vascular bundles. Vascular bundles will be present here. 3, 4, 5, 6, 7. I should have drawn 8, but this is also okay. Now xylem will be present here. This part is xylem. Xylem. Xylem is present here. Like this. Xylem is present here. And beside the xylem, there is the phloem. So phloem is present outside. So like I have always used red color for representing phloem. So phloem is present in this part. And between xylem and phloem, the white colored part that I have left out purposely, that is the cambium. That is the cambium. Okay, I can choose a different color for that cambium now. So let me take some different color to draw it. Yeah, this will be fine. So this is the cambium. This is the cambium. Now ultra structure, the complete cellular structure with all the details I will draw in the next class. And the central part, it will be called the pith. So you can see the pericycle is not continuous here. Pericycle was continuous in the root. Between root and shoot, there are a lot of differences. There are a lot of differences there. So let's write a few things here. This is the pith. Collenchyma is done. Then there is the cortex. This is the part, it is called the, what is it called? Yeah, endodermis. This is the pericycle. Pericycle. And pericycle is made up of sclerenchyma. Sclerenchyma. Okay. In the root, it was made up of parenchymatous cells. Here it is made up of sclerenchyma cells. So there is a difference. The red colored part, as always, it is phloem. This color, it is for cambium. And the black colored part, as usual, it is for xylem. Okay. So this is the structure of that dicot stem structure, transverse section. And yeah, it looks a bit colorful, I agree. So I had to do it. I needed to show you this. Right. So after this, we will do in the next class. Okay. This is only for this. I had to give you an outline. So if you understand the outline, it will be easy to understand the transverse section, full structure. Okay. It will become easier. So please finish this quickly. And after that, we will do in the next class. Okay. So yeah. So this is complete now. Also there is a bit of difficulty in the chat also. So I will have to actually ask you a few questions also regarding this. So I will, in the next class, I will ask you to do some questions. I will ask you differences between stem and root and between monocot stem, dicot stem. So this is your homework. Try to find out differences between monocot stem and dicot stem, and try to find out differences between stem and root in general. So in general, when you see it, talk with reference to the vascular bundles. And if I ask specifically difference between dicot stem and dicot root, difference between monocot stem and monocot root, so then you should be able to answer these type of questions. Okay, because a lot of options are framed on this knowledge. There are a lot of options you will find that are framed on this knowledge. So yeah, there is a bit of spelling problem, I believe. This is trichome, M, trichomes, trichomes, M is there, not N. So I believe you have drawn this. So after this we'll meet in the next class and we'll discuss these differences and the points where the questions are being framed from this topic. Okay. So thank you dear students, thank you for your time. So in the next class, if you have any doubts, please feel free to reach me out and I'll be able to help you in whatever way I can. So thank you. See you in the next class. Thank you.